Hi guys, I'm Deb. Today we'll learn about probability. What is probability? The probability of an outcome is the proportion of times the outcome would occur if we observe the random process an infinite number of times. So this is important, an infinite number of times. Sample space is all possible outcomes of an event. So for example, when you flip a coin, we have two sample points, head and tail. So chance of getting head is 1 by 2. 2 because we have two sample points. So if we flip a coin 10 times, then we may get all 10 heads. So we need to go back to the definition again. We need to flip a coin for a larger amount of time. So then only we'll get near to the half. Another example would be rolling a pair die. So when we roll a pair die, we have six sample points: one, 2, 3, 4, 5, 6. So chance of getting 2 is 1 by 6. One thing we should notice here, it is a pair die, not a cheated one. So disjoint events. Two outcomes are called disjoint or mutually exclusive if they cannot both happen at the same time. The two examples we just saw are disjoint events because uh, for this example, when we roll a pair die, we cannot get one and two at the same time. We'll only get one or two. So the question is, so chance of getting either one or two when rolling a die is probability of one or two, which equals to probability of one plus probability of two. So 1 by 6 plus 1 by 6 equals to 2 by 3. So this is called addition rule for distant events. And if we ask, so what is the chance of getting 1 and 2 when rolling a die? And this is 0. Non-distant events. So consider this sample space. In sample space, we have white cat, red cat, black cat, white dog, and black dog. So what is the probability of getting a black pet and a cat? If we apply the addition rule for disjoint events, then we may calculate the probability of black cat two times. You can see that black cat is also a black pet and also a cat. So for non-disjoint events, we need to subtract this intersection. So probability of getting a black pet and a cat is probability of black pet plus probability of cat minus probability of black pet and cat, which is 2 by 5 plus 3 by 5 minus 1 by 5. Conditional probability and Bayes theorem are beyond the scope of this tutorial. These two are very important for statistics. Please go through the links in the description and add a comment if you have any doubt. Random variable is a set of possible numerical outcomes from a random process. For example, tossing a coin. So let's assign 1 to head and 0 to tail. Then random variable x is 1 and 0. Let's consider an unpaired die. Previously, we were considering a paired die. So each outcome has the same probability. So here, let's assign 5. Let's assign 0.2 probability for 5 and 0.4 to 6. Okay, so mean is sometimes called expected value. So and this table is called probability distribution. So mean is summation of xi pi. So we need to multiply outcomes with its corresponding probability. So now we have 4.4. So we're more likely to get 5 and 6. Variance measures the spread and variability of a distribution, and it is measured as summation of uh, xi minus square of xi minus mu cross pi. So if we calculate for our distribution, this distribution it is 3.04. The standard deviation sigma is the square root of the variance, so it is 1.74. The the random variable we just saw, it is a discrete random variable, but here it is a continuous random variable. If we consider points between 0 to 1, we have infinite numbers. So let's consider age of a population, and this is the histogram of this distribution, and each column or bar is bin, and the height of bin represents the density of the population for that category. So if we consider 13 age group, the density is around 2, and if we consider 15, density is around 4. The shape of this distribution looks more like bell curve. So you can see it is a bell curve. So that means this distribution can be approximated by a normal distribution. This is not perfectly normal, but an approximately normal. In normal distribution, this is a perfectly bell curved shape. So this is the mean, and in one standard deviation, we have 68% of the population, and 95% of the population is within two standard deviation, and 99.7% of the data are within three standard deviations of the mean. And still, we have some data beyond three standard deviation. Let's draw a histogram for age of the population in Python. So we need to import these libraries. Age is a list. Stats library is used to calculate the density for each category. Norm is for normal distribution. PDF is for probability distribution function. And we can use NumPy to calculate mean and standard deviation from the age. STT is for standard deviation. Let's print the feed to actually see what it holds. So it shows the density for each category. We can feed the data using the plot function, and dash is for solid line, O is for circle marker. You can see the circle here, and R is for red. We have a red line. Hist function is used to draw the histogram, and we need to call the show function to actually draw on our screen. And that's all about basics of probability. Next session is on linear regression. Thanks for watching.